Hi, and welcome to Thursday's Maths with Kirin. So Thursdays is the sort of question and answer session. So I've got 4 questions today to go through with you. They are from the 2015 and the 2016 assessment papers, all paper A. So if you want to practice these skills, you can go and have a look at paper B. They'll have similar questions, but they'll be slightly different. So you can have a go at them yourself. So I think we'll just get straight into it. So the first question, Sammy and Marius earn pocket money by working in a garden. Marius earns $14 an hour. Sammy earns $4 an hour more than Marius. Marius works twice as long as Sammy. Together they earn a total of $138. How much does Sammy earn? So in this question, it's asking how much Sammy earns. We know that Sammy earns $4 an hour more than Marius. We can't just say Sammy earns $18 an hour. We need to work out from the information that we're given how much Sammy will earn in total, not just per hour. Okay, so the first thing that you might note is that Sammy earns $18 an hour, the terrible dollar sign. That's important. And then these 2 bits of information here are where we're going to write our equations from. So because we've got 2 people, we've got Sammy and we've got Marius, we need to write a pair of simultaneous equations and solve them in order to work out how long Sammy works for. And then once we know that, we can use the $18 an hour in order to answer the question. So Marius works twice as long as Sammy. So if Marius works for 8 hours, then Sammy would work for 4 hours, okay? Or if Sammy worked for 2 hours, then Marius would have to work for 4 hours because Marius is doing twice as long as Sammy. So that means if we have M is the number of hours Marius works, and instead of using S so I don't get it confused with a 5, I'm just going to write A for Sammy. So A is the number of hours that Sammy works. If Marius is working twice as long as Sammy, we need to multiply the number of hours that Sammy is working by 2, and that will be equal to the number of hours that Marius works. Okay, because Marius is working twice as long. So in order for those to be equal, we need to double the number of hours that Sammy works. Together they earn a total of $138. So we know that Marius earns $14 an hour. So 14 times the number of hours that Marius works plus 18 times the number of hours that Sammy works will give us the $138 that they get. So here are our 2 equations. We already have M as the subject of this first one, so we don't even need to rearrange. We are just going to replace our M here with our 2A because they're equivalent, and then we've got an expression with A's and we can solve. So 14 times 2A plus 18A is equal to 138. Okay, 14 times 2 is 28, so 28A plus 18A is equal to 138. 28 plus 18, well 20 and 10 is 30, and 8 and 8 is 16, so we've got 36A is equal to 138. So A is 138 divided by 36. Okay, so you might have to work it out. You might not be that good at dividing by 36. You might break it up into smaller numbers and just keep going, but you should end up with 3. So 138 divided by 36 is 3. So we know that Sammy works for 3 hours. Okay, now the question is asking how much Sammy earns. So Marius obviously works for 6 hours, but we don't actually need to use that. We just need to know how many hours Sammy earns. So, how many hours Sammy works. And now we know that Sammy earns 3 times $18 an hour, which is 54. So Sammy earns $54. That's the answer to that question. So for achieved, you give one equation. So either 2A equals M or this one here, 14M plus 18A is Okay, you might not have M and A. You can have whatever you like, X and Y. You might use M and S. That's fine, up to you. Or you have a consistent use of a variable between the hours worked and the money earned. So instead of setting up simultaneous equations, you might sort of just have X as the number of hours worked by Marius and use that all the way through, so that you essentially only end up with X in your equations, not M's and A's. For merit, you form your relationship into one variable. So that's getting down to this step here, so that we've eliminated that M. We've only got A's to deal with. Or you solve the problem, but you solve it for Marius. Semi, and then for excellence, you get to your $50, okay, all the way through that question. So the second question today is also from the 2015 paper. Sarah and Marie are studying for the NCEA exams. Sarah claims she does more study, and Marie says she does 3 hours study on each of the 4 days during the week. Sarah says she studies for 2/3 of that time during the week and at least a further 2 hours on the weekend. Is Sarah's claim always correct? And they've asked us to explain our solution. So Marie, I think that's how you pronounce that, does 3 hours on each of the 4 days, so she does 12 hours of study. Sarah is a little bit different. It says she studies for 2/3 of that time and at least a further 2 hours on the weekend. So she studies for at least 2/3 of the 12 hours plus 2 hours on the weekend. Okay, so at least, which means greater than or equal to, which is why we have that inequality there. So 2/3 of 12, or 12 divided by 3 is 4, times 2 is 8. So Sarah studies for at least 8 plus 2, which is 10 hours. So she studies for at least 10 hours, and she's claiming that she does more study than Marie. So her claim is not always correct. And the question is asking us to explain our solution. So if she does between 2 and 4 hours, because remember Marie studies for 12 hours. So if Sarah studies between 2 and 4 hours in the weekend, she studies less than Marie. If she studies for exactly 4 hours, she studies the same as Marie. And if she studies for more than 4 hours, she studies for longer than Marie. Okay, so that explaining bit, you've actually got 3 parts to it. Because her claim is not always correct, we want to state at the very least that anything less than 4 hours of study for Sarah means that she'll study less than Marie in total, and anything more than 4 hours means that she'll study more than Marie in total. And then, of course, it's also good to add in if you study for 4 hours, exactly not being the same. So for this question, to get achieved, you have an algebraic inequality. Because Sarah is talking about at least a further 2 hours on the weekend, that's your clue that you need an inequality. Or if you don't do that, your statement as to whether the claim is correct or not is justified given the number of hours in the weekend. So if you don't have an inequality here, but you are justifying these statements, then that can be achieved. For merit, you need an inequality and one of those statements, or you need a positive and a negative statement. So the less than 4 hours and the more than 4 hours statement, merit. And then for excellence, you have to have a complete response with an inequality and both of those scenarios. Okay, less than 4 hours and more than 4 hours, and how that will impact Sarah's claim. Okay, so not a simultaneous equation as such, more of an inequality for that question. So having a look at a question from the 2016 paper now. So this is again about money. Renee, I think that's how you might say that, has more money than Hone. If Renee gave Hone $20, they would have the same amount. If instead Hone gave Renee $22, Renee would then have twice as much as Hone. How much money does each person actually have? Okay, so we've got two people, two different quantities of money. So we're looking at writing a simultaneous equation. So if we just define our variables, I'm going to use R for Renee's money and H for Hone. So the first thing, if Renee gave Hone $20, they would have the same amount. So Renee's got a particular amount of money. I'm going to give $20. So I need to take $20 away from that, and I need to add it here. So that's our first equation. Our second equation comes from this. If instead Hone gave Renee $22, so we take $22 away here, and we put it here. Renee would then have twice as much. Okay, so if Renee's got twice as much, then we need to multiply this by 2 in order for them to be even, because this is obviously more. So now we've got two equations. We can expand and simplify that one out. If we're using substitution, because that's the skill that we went through in yesterday's lesson, we can rearrange the top equation and we can either make R the subject or H the subject. It doesn't matter. I'm going to rearrange and make R the subject. So R is equal to H plus 20, and when I bring that 20 across, I add another 20, so we've got plus 40. And now we can substitute, and here instead of this R, we're going to replace it with H plus 40. Okay, so I'll do that over here. So we've got H plus 40, which is our R, plus 22 is equal to 2 times H minus 22. So if we simplify this out, we've got H plus 62 is equal to 2H minus 44. Bringing our 2H to the left-hand side, we have negative H. And taking our 62 to the right-hand side, we would have negative. We need to subtract it. Negative 106. That's an H. Which means H, positive H, is positive 106. Okay, now if we know that, we can go back to R, because R is H plus 40, which is 106 plus 40, so 146. Okay, so Hone has 106, and Renee has 146. Right, if you're unsure, you can substitute those back into both of your equations and make sure that they work. But I do happen to know that they're the correct answers. So for this question, for achieved, you need to get at least one equation correct. So writing one of those two equations is achieved. Or you have incorrect equations, but you can combine and simplify them. So often what happens with a question like this is that we forget to subtract the 20 and we forget to subtract the 22 here. So you might have R equals H plus 20 and R plus 22 equals 2 times H. Okay, so those equations are technically incorrect, but if you can use those both and combine them, then you can still get achieved for the question. To get merit, the amount of either person found, so you either get the 106 or the 146 with algebraic working, so one but not both, or you have consistent solutions with only one correct equation, so maybe instead of multiplying by 2 on this side, you did it on this side, and you followed that through. Then that would give you merit as well. Or you have two incorrect equations, but they're both related to the problem. So again, if we had that situation where we forgot to subtract 20 and subtract 22, you followed that all the way through and you got two answers. If you did that, you would get H is 42 and R is 62. That could still be merit. And then for excellence, you get the correct solutions. No alternative, just both of those are required. Oh, and the last question for today, from the 2016 question. Brooke knows that the time it takes for a pendulum to swing from one side to the other and back is given by the formula T equals 2 pi times the square root of L over 9.8, where L is the length of the string. So here's our picture of our pendulum here. Write a formula that she could use to find the length of the string in terms of the time T taken for one swing. Okay, so write a formula she could use to find the length of the string in terms of the time T taken for one swing. So it's asking us, L is the length of the string. We want to rearrange this to make L the subject of this equation. So the first thing we'll do is the 2 pi. We need to bring that across by dividing through. So T over 2 pi is equal to the square root of L over 9.8. Okay, the next thing is to deal with the square root. So we need to square both sides. So T over 2 pi all squared is equal to L over 9.8. Now you can just leave it, you don't have to square it out. If you did, you'd get T squared over 4 pi squared, but you don't actually have to simplify that. You can leave it as a square. Moving the 9.8, at the moment we're dividing L by 9.8, so we want to multiply both sides. So we get 9.8 times T over 2 pi squared is equal to L. Okay, so you can leave your answer like that. You don't have to do anything else. And so for this question, achieved, you have to have some progress in your rearrangement. So it might be moving the 2 pi correctly to the left-hand side. Some sort of good progress. For merit, you have one error in your rearranged formula, but you must make sure that you have the square from the square root. Okay, so one error, but that can't be it. Okay, so you must have the square. But maybe you put the 9.8 inside something for your one error, and then for excellence, the correct rearrangement. That's required. So those are all of the questions I have for today's session. On Monday, I will be back doing some more simultaneous equations, but we're going to be looking at the elimination method. So as I said yesterday, good to be able to use both substitution and elimination because different equations will lend themselves to one method sometimes over another. They'll make it a little bit easier for you when you're solving things. So that's on Monday, and then Wednesday we've got problem solving style questions. So questions that sometimes come up that might not fit so nicely into some of the other categories. So if you come across something that's a little bit tricky and you're not quite sure how to solve it, just email it through to me and I'm happy to go through that next Thursday in the Thursday session. Otherwise, I hope to see some of you on Monday or Wednesday or both. Great. Thanks for watching. Please subscribe, share. Even though I've only got 2 lessons left, you can obviously share and you can watch the other videos that are up on the page or on the YouTube channel. So please do keep sharing. I know that MCAT is coming around quite quickly. So share away and let's try and get as many people feeling as prepared as we can with MCAT. Have a lovely weekend and I hope to see some people on Monday.